that'll get me my length of RV, which will be 8. And let's pull out the solution over here and see what they have over here just to see if we're good. And there you go. There's my SV is 24 and my RV is 8. So that's what I was looking for. Alright, so now we're going to plot the coordinates of the centroid C of triangle DEF, and again, plot the points. So normally, you guys will copy this down, plot the points, it's already done. Calculate the midpoint of DF using the midpoint formula, and so find the length of DF, find the middle, which would be using the midpoint formula, which would be right here. This is just going through the steps again. Find the distance from E to J in this case, and so that's another vertical line, so we can just count 1, 2, 3, 4, 5, 6. So that would be that the midpoint, the distance from E to J is 6 units, and then if I take 2/3 of that will give me where my centroid is, and so 2/3 of 6 ends up being 4, and again if I count down 4, 1, 2, 3, 4 from E, there is where my centroid is, and I just need to find the address, which would be 5 over 1, 2, 3 up, which would be D down here. Okay, so same thing we've been doing, just kind of looking at it a little differently. Alright, so then we have a new one with altitudes. Now think about what an altitude is. An altitude is the height of something. Think when you're flying in a plane and you hear the altitude of this plane is 10,000 feet or whatever. So that means 30,000 feet. And so that means the height from the ground at a 90-degree angle. And that's what we're talking about when we're talking about altitudes of triangles. So the lines containing the altitudes of a triangle are concurrent. And then basically they'll all intersect at the same point is really all we're saying. So this is called the orthocenter. And is the orthocenter of ABC located inside, outside, or on the triangle? Now, the reason they're asking this is because if you the orthocenter can end up in a different spot depending on where the triangle, where the altitudes are. So I'm going to do my best to sketch a 90-degree angle to each of the opposite sides. And I'm not exactly sure where these guys are going. And you'll notice that if I can't get a 90-degree angle from A, see, like I can't get a 90-degree angle to run into that. I'm going to have to extend that side with something, and I'll use a pink line here. Extend that side, try to do it as straight as I can, to make my line run into it at a 90-degree angle. And that looks pretty good. So this guy is actually going to have to be extended the other direction. Let me move this whole thing down so we have a little more room. To get that orthocenter, because there's my 90-degree angle, I'm going to have to extend beyond my 90-degree angle to have these guys run into each other. And again, I'm going to have to, looks like because this side, I'm going to have to extend the side again. And to get my orthocenter, to get a 90-degree angle to the side opposite it, I can't do it inside again because you're like, there's no 90-degree angles in here. The 90-degree angle doesn't happen until out here. And then if I draw my line, you can see that my orthocenter is this point right here. Missed it by a little bit, but that point right there is my orthocenter where all three altitudes meet. They're going from a corner to the opposite side at a 90-degree angle. All of these guys should be pretty darn close to 90-degree angles to the side opposite it, and that's what basically they're trying to show you up here. So if the thing is an obtuse triangle, the orthocenter is going to be outside, and it'll always be outside. So obtuse, outside. Okay, and so then the next one says find the orthocenter of an acute, a right, and an obtuse. Well, we've already done obtuse. That was in the previous one, so we're not going to bother with that one. We'll go ahead and do a right triangle. Do my best to do a right triangle, and then the next one we'll try to do an acute triangle. Something that looks like that. Okay, so there's our two. and two triangles. We've already done the other one. And so now I'm going to draw, well, with a right triangle, if I take this right triangle and I want an altitude from this corner, the altitude to meet the opposite side is right here, because there's my 90-degree angle. There's from the corner to the opposite side. Same thing with this one. Okay, that's not so bad. If I could actually draw a straight line, that would work out. And so I'm going to try to move that line over a little bit, so I'm there. So there's my two of my altitudes. And so then my third altitude, in order to take this corner and meet at the opposite side at a 90-degree angle, something like that, you'll notice that all three of my red lines meet on the triangle. And so that's the trick. Right triangles. Come on. What's going on here? The thing doesn't want to write today. Right triangles. This is on. I don't know why it is not writing. Try one more time here. Okay, well, right triangle is on, and then if we are doing the acute triangles, obtuse was outside. If I do acute triangles to the opposite side at a 90-degree angle, something like that, and like that, the acute triangles are on. So you can see that in an acute triangle, when all the angles are less than 90 degrees, you'll end up with the orthocenter being inside. If it is a right triangle, it'll end up on, and just like we talked about in the previous one, in an acute triangle, or an obtuse triangle, the orthocenter is outside, and you can see the triangle is the black one, and the point orthocenter is way out here. Okay, and you can see that from the previous one that we did. So moving along here, so this is the median review, centroid again. If SC is 210 feet, what is the length of PS and PC? So SC all the way across is 210. What is the length of SP and PC? Well, this is the 2/3, 1/3. So if I can take 1/3 of 2100, that will give me PS. If I can take 2/3 of 2100, that will give me PC. And basically 1/3 this one, so for A, PS is 700, and this one would be 1400. So now BT in this one, ooh, the outside piece is 1,000 feet. TC would be how much? Well, what do we know about this point T? Well, this point T should be the median, which meets the opposite side in the middle, so that would mean that TC would also be 1,000. BC then would be 1,000 plus 1,000, which is 2,000. And finally, if PT, this distance right here, is 800, find PA and TA. Well, we know that PT is 1/3 of TA, so PT equals 1/3 of AT, we'll say. And so if I put 800 here, equals AT divided by 3. If I multiply this by 3, 2,400 equals AT, which is the length of the whole line. And then if I divide that by, if I do 2/3 of that, or subtract 800 from 2,400, that'll give me AP. So AP is actually going to be 2,400 minus 800, which is 1,600. Okay, so moving along here. All right, so here we are. We're on the out, and so copy and complete this table to the left. It's in your book, and so I'm going to let you guys copy that for your out, draw the pictures and everything, and we'll have homework that we will do in class. So hope you guys enjoyed this webinar, and sorry about all the little mistakes that I did in there today, but have a good day.